Welcome to the next lesson, where I'm going to introduce you to the application that we will build as part of this course. My firm belief is that the best way to learn something is by building it from scratch. And that's exactly how I'm going to approach the remainder of this course. I want to make this an interesting learning experience from you, so I'm going to guide you through implementing a RESTful API starting from a blank Visual Studio solution, building all the way up to a level 3 completely RESTful compliant Hypermedia enabled API. Here are the topics that I want to cover in this lesson. I want to lay out the requirements for the application that we are going to build, and I'll focus mostly on the functional requirements, and we're going to fill in the rest as we go. Then I want to give you a brief preview of the API endpoints that we're going to develop as part of this course. And I also want to give you a brief preview of the user interface that we are going to integrate with the RESTful API that we will build. I wanted to include a user interface to make this a complete discussion about building APIs, because most back-end oriented courses solely focus on APIs and interacting with a database. I figured this would give a new dimension to the course. So what are our requirements? We're going to build a developer habit tracking API, which I will call DevHabit. If this name is already taken by some application out there, the similarities between them are entirely accidental. So what is DevHabit? It's a RESTful API designed to help developers track their professional development habits, set goals, and monitor their progress. Let's break this down further into individual functional requirements that we have to support. We will need to build user management and authentication, habit tracking and habit management, goal setting and progress monitoring, entry logging and tracking our streaks. We need to be able to organize this using some tagging system, and we also want to support batch operations for quicker entry. Now, I'm also going to leave a markdown document under this video. This is going to contain a more detailed set of requirements if you want to tackle these requirements yourself. I will also list out the minimal set of API endpoints that we should support in order to implement this. Having said that, here's a preview of the API endpoints that we will build as part of this course. You can see there aren't too many resources, so it shouldn't be too hard to follow along with the implementation. And I will strive to mostly use a standard set of HTTP methods, which are get, post, put, delete, and batch. But we're going to discuss other HTTP methods and when you may want to implement them. Also, here's a mock-up of what the user interface could look like. It should allow us to observe what are the current habits that we are tracking, perhaps include some statistics of what we should be focusing on today, or what are some goals that we have completed. And of course, it should help us implement the functional requirements that I mentioned previously. Here's another mock-up of what the user interface could look like, containing the most recent entries for the habits that we want to track. And I wanted to mention that we will not be building the complete user interface as part of this course, as this is not the main topic of pragmatic REST APIs. What I will do is show you how to run an almost completed UI application that interacts with our REST API, and we are going to implement only some of the functional requirements as part of this course, where I'm going to focus on the interesting details when it comes to interacting with Hypermedia, API versioning, and change management, and really the main focus will be on highlighting the interesting and powerful aspects of RESTful APIs. I think this was more than enough theory about RESTful APIs, and it's time to move on to some more practical topics. And we're going to start with our next lesson, where we will tackle setting up the project that we will use to build our RESTful API. Welcome to the final lesson of this chapter, where we are going to set up the project that is going to serve as the foundation for the DevHabit RESTful API that we will be building throughout this course. I wanted to give you a heads up before we start coding that this lesson is going to be slightly longer. There are a lot of topics that I want to cover as part of this lesson, starting with the project setup. We're going to begin by scaffolding the ASP.NET Core Web API. Then I will move into setting up the build configuration. We're going to create the directory build props file, and this will allow us to extract some common configuration settings from our .NET projects into this XML file that will contain the necessary settings. The next thing we're going to introduce is support for central package management, and this is going to make a couple of things easier for us. First of all, it's going to make it easier to manage NuGet package versions. Whenever we want to make an update, we'll be able to do so inside of one place. This will be the directory packages props file, which is the core file for supporting central package management. Together with the directory build props file, this will make it surprisingly simple to evolve our project. For example, when a new .NET version comes out, we can update the target framework in one place and simply update the NuGet packages from one file. You will see how all of this falls in place when we move into the implementation. After this initial setup, we're going to move into enforcing code quality through the build tools that we have available, we're going to create an editor config file, and we're going to set up some static code analysis. Then we are going to containerize our .NET application so that we can easily orchestrate it using Docker Compose. This will also make it easier to run some external services that I want to introduce during the development of the DevHabit RESTful API. We're also going to spend a little bit of time to set up observability in our solution by introducing OpenTelemetry, and I will give you two options for exporting your telemetry data into Seek or the Aspire dashboard, where you will be able to choose which one you like better. And we're going to finish off by setting up our CI/CD pipeline and running it inside of GitHub Actions. So let's jump into Visual Studio and start writing some code. This is my starting point. I have an empty Visual Studio solution called DevHabit. Behind the scenes, I set up my GitHub repository, so when I am done building everything, I will be able to commit my code and push it to the repository and trigger the CI/CD pipeline that we are going to introduce a bit later. But for now, let's actually add our API project. I'm going to right-click on my solution, then click Add and choose a new project, and I'm going to choose the ASP.NET Core Web API template. Let's click Next. I want to create it at the root of my folder, and I'm going to call this project DevHabit API. Let's click Next. I will be running this on .NET 9, which is the latest .NET version at the time of recording this video. However, I'm going to set this up in such a way that's going to make it trivially easy to upgrade this into .NET 10 and beyond, or even downgrade to .NET 8 if you want to run an LTS version of .NET. I'm going to explain how in just a moment, but let's stick with .NET 9. Then I'm going to configure HTTPS, and I won't be setting up any authentication. I could enable container support, and I will be targeting Linux as the operating system. And you have two choices here. Either build your container using the .NET SDK, which is a newer option, or use a Docker file. Now I'm going to be using a Docker file because it gives me a little bit more control, but I will be adding this later, so I'm going to uncheck this option. We will use Open API support, so I'm going to check this. And I want to be using controllers instead of minimal APIs, so I'm going to tick this box as well. Now, when it comes to controllers versus minimal APIs, I feel that controllers are still significantly more popular for building APIs in .NET. So this is why I am choosing controllers, but I will add a bonus section in the end to show you how you can easily translate an API from using controllers into using minimal APIs. So no worries there, but for now, let's stick with controllers. So this is my project setup. Let's create it. And this is what gets scaffolded out of the box. Let's open up the program file. And here you can see we have our controller services, OpenAPI, which replaces Swagger starting from .NET 9. Then we're building our web app, setting up the OpenAPI endpoint in development environment, using HTTPS redirection, authorization, mapping the controllers that we have, and finally running the application. So let's go ahead and make a couple of changes. First, I'm going to get rid of any comments that I currently have because I have no use for them. Then I'm going to get rid of the authorization middleware because I don't want to be using it right now. We're going to set this up later when we discuss authentication and authorization. And this is what I'm left with in the program file. Let's check out the controller that we have. It's just a weather controller. I'm going to update it to use a file scoped namespace. And here you can see that we are inheriting from the controller base class. And we're also decorating this with an API controller attribute. This introduces some interesting behavior on your controllers. They become so-called API controllers, whereas without it, they would be treated as MVC controllers. We're going to talk more about this in the future lessons. Now, I will leave in place this single endpoint that we have. And the next thing I want to do is update the launch settings of my application to target some specific ports. I like using the ports 5000 and 5001 for my applications. So I'm going to set up these specific ports in the launch setting. So now when I run the application, it's going to be available on these ports. If you want to use an HTTP file, go ahead and update the API endpoint there. And if I press Ctrl F5, this is going to start the API without debugging. and I should be able to send a request here and get back a response. So you can confirm that your application is working. I will go ahead and stop this. And now that we are confident that our application is working as expected, let's discuss some of the things that we want to set up. First, I'm going to introduce a logical folder in the solution called SRC, which is short for source, and this is where my API project is going to live. Then let's take a look at the NuGet packages that we have installed inside of this project. You can see that there's only one, which is the OpenAPI package, and this allows us to view the OpenAPI specification for our API. Now this will be very important for documenting our API so that the clients can integrate with it, and it also opens up some interesting options such as generating API clients using the OpenAPI spec. Now if I were to start the application and navigate to my base address /OpenAPI/version1 JSON, which is what you're seeing here. This is what the OpenAPI specification looks like for our current API. You can see both of the base addresses that we have exposed on the ports 5000 and 5001. And then we have the one API path, which is weather forecast, with a get endpoint, which describes the response that's returned by this API endpoint. The specific response is described in a schema, which you can see below. Inside of components and schemas, there is the weather forecast object, and this is the OpenAPI description for the weather forecast schema. It lays out the properties on this type and the data types that we are using. So OpenAPI is a specification for describing HTTP APIs. We're going to talk more about this when we discuss documenting our REST API. So now let's introduce a couple of best practices that I like to follow when setting up a new project. And I want to start with configuring build configuration. So I will add a new item to my solution, and this is going to be an XML file. I'm going to call this directory build props, and I'm going to paste in the contents of this file, and then let me discuss what is it that we introduced. The directory build props file allows me to configure some high-level properties for all of my .NET projects. For example, I can set the target framework, if I want to use implicit usings or nullable reference types, and I can also set some code quality settings, which are mainly concerned with static code analysis. So let's save this file, and now this is going to apply to all of the projects that I have in my solution. If I go back to the DevHabit API project, you can see that I have some redundant properties now, like the target framework, nullable reference types, or implicit usings. And because I have them defined in my directory build props, I can go ahead and remove them. Now, if I attempt to build my project, you will see that I will get back some errors. This is because I turned on the treat warnings as errors property, and this is going to treat my static code analysis warnings as errors. So let's take a look at one of them. For example, this one here that states that I shouldn't be using random for generating random values. What you can do instead is use the random number generator, and it has the getInt_free2 method, which can replace random shared next. So let's go ahead and do that. I'm going to update the other reference we have to random. And now if I build a project, you will see that these errors or warnings are removed. We are left with another one, which relates to our controller. And this particular static code analyzer is something that we could turn off, because it's saying that our API shouldn't be publicly referenced from other assemblies. And the reason we're getting this warning is because this type isn't referenced by any other assembly, so we can make it internal. So if I wanted to make this go away, I can make this internal, but this will only let some other errors bubble up. So we are going to solve this differently. Let's revert this back to public, and let's move on to the next thing I want to set up, which is central package management. So I'm going to add another solution level item. Let's click new item. You can pick an XML file because we are pasting in XML, and this one will be called directory packages props. And I will go ahead and replace this XML with this one. So here I want to apply a property group to all of the projects in my solution, and what I'm setting up is manage package versions centrally, and I want to set this to true. So now this will allow me to manage all of the NuGet packages in my solution from this one file. What I need to do is define an item group where I'm going to manage my package versions, and what we can do is move the one package that we have, the Microsoft ASP.NET Core OpenAPI package, and move it into the directory packages props file. We have to update this from a package reference property into